travels. If you don't include that in your diagram, you can see that my curve is terrible in my diagram too, so no worries. Never going to judge your drawing, because mine sucks worse. But what we also observe is that while at C we will have an S wave, in A we will have an S wave, at B there is no S wave. That means that the dotted line goes from here to here, here to here, but there's nothing over here. So there must be something on the inside that's blocking the center from passing straight through the center and to the other side of Earth. This over here is known as the S wave shadow. Now, what does that really mean, and what about the outer core is causing this to happen? Okay, this was actually figured out by a Danish mathematician turned geologist named Inge Lehmann. Now that's not, I don't test you on people on a test, right? It's not like, this is not a history of science course, right? But where might it show up? Extra credit, excellent. So Inge Lehmann observed this phenomenon, and using what she knew about S waves, that shear waves can't travel through liquid, figured out the outer core must be liquid, which at first was totally not accepted. Okay, and some of the reasons why it was totally was not accepted is that some scientists were having a hard time imagining that we have this solid mantle and then suddenly we have this liquid outer core. That's part of it. And the other part of it was related to the fact that, what kind of name is Inge? Female. Yeah, and that was a problem too. I mean, she was a female mathematician at a time where female mathematicians were, it was like her and Madame Curie, and then there wasn't a whole lot of other folk around. So, and actually she's about 30 years, 40 years after Madame Curie. But she kept proposing this, and she kept on backing it up with more and more data, and finally it was finally accepted, and it was such a revolutionary concept that the #1 prize now in geophysics is actually the Inge Lehmann Award in geophysics, okay, because of her contributions. This is predominantly what most people think about when we talk about the undergraduate level. She did a lot more for understanding the interior structure of the Earth than just that the outer core was liquid. But by combining mathematics with geology, she really revolutionized our understanding of the interior Earth. So, any questions about this? Are you ready for starting the activity? You keep moving? Let's keep moving. Boldly go forward. So we have one last page here to look at before we get to the activity, just to make sure that we're visualizing the inside of the Earth correctly. So I was telling, was it Veronica or Abigail, which one of you had the question about how deep the mantle went and how, not sure. Okay, so over here, this is what the inside of the Earth looks like. Okay, very basic. This is not even quite to scale, because if you look at the crust is really like relative to the whole Earth, like the thickness of an eggshell on an egg, or even more like the skin on an apple. It's very, very, very thin. We're only talking about 12 kilometers on a planet whose radius is about 6,000 kilometers, okay? So we're talking about a teeny tiny thin layer on the outside. Then we have this upper mantle in here, and if you're trying to think of this as lithosphere and asthenosphere rather than crust and mantle, this and the very tippy top of the upper mantle is the lithosphere, and then this down here, only down to the transition zone, not the whole mantle, is the asthenosphere. Now, which parts of this are solid and which are liquid?
The crust and the upper mantle solid.
The crust and undermantle is solid. Good. What else is solid?
The lower mantle.
Excellent.
And the inner core.
Inner core. Excellent. So the only part that's liquid is the outer core. Now, some parts are more plastic, they're more bendy, and definitely in parts of the mantle you have what's called partial melting, which is a little bit like rock slurpy, due to increases in temperature and decreases in pressure and that sort of thing. But most of it is pretty gosh darn solid. Now, if we head over here and go over to this activity, the last activity we're going to do, which is our earthquake activity, earthquake and plates. And this is really cool because actually earlier this semester we hadn't talked about this yet. There was it was tragic and destructive in that sense, but also geologically, holy cow, impressive and awesome, that actually involved the plates we're going to be talking about today, which are the Cocos Plate and the Caribbean Plate, where the Cocos Plate actually fractured during the major geologists hadn't seen that before, like the plate split during the major earthquake down in Mexico recently. But we're going to consider it one big plate, and because we haven't mapped how far that crack goes yet, and ask questions about and try to understand how the plates look, what a plate is, and how that's different from a continent, and how those two interact. Now, parts of this that will help you out, parts of this that will probably help you out are the plate tectonics map. The plate tectonics map, if you have, how many people brought their book today? A couple of you. That's okay, I have an extra book. And I can put a map of the plate boundaries up on the screen to help you. But you are going to want to work with a buddy with a book. So the plate tectonic map is in chapter 7. In my edition, this is chapter 9. It is on page, here we go, page 218 in edition 14, and it looks like this, okay? And I'm going to warn you right off the bat, this is a little deceptive, because when you sketch the south plate of South America, it looks like there's a gap over here. This is the edge of the plate, this blue and green line over here. Okay, and this gap looks like there's a gap in there. There's not. Okay, this continent goes right up against that edge there. So when you sketch this out, make sure you think of that. The other thing you will need, sections on plate boundaries. Those are the big sections are 7.5. And 7.6. And what you're really wanting to look at is the figures. So for example, there's some questions about island and continental arc formation these are the diagrams you want to be looking at, okay? And remember, we're focusing on cross sections. And don't worry, we'll have time to review this on Wednesday as well. So we'll talk about that a little more on Wednesday. And then the last diagram that you need to do these activities is the earthquake belts and plate boundaries map, which is in chapter 8. It looks like this. And keep in mind, all of these little dots are earthquakes. People tend to focus on this. This just means that there's a whole buttload of earthquakes here, okay? There's earthquakes all along here as well and over here. All these little lines over here are earthquakes. Make sense? And that's on page 261 in my edition. So in this activity, the first step is to draw the continents of South America draw the South American plate with the continents of South America on it. Raise your hand when you're done. Use your book as your guide. This first sketch, which I really recommend in pencil, is a check. It's a quick check to make sure that when you add color to it. First of all, I'm checking, do you understand the difference between a plate and a continent? But after, another level is you want to get it checked because you don't want to put color on something that's incorrect because that's a pain in the butt. Number 2, on the drawing you just made, add the following: outline convergent in blue, outline divergent in red. There's a test, are you paying attention? Green X's mean earthquakes, not transform plate boundaries, so keep alert. Number 3, using what you just learned, fill out the table below, put an X for each feature that is found with that plate boundary. We can also, so the mapping activity as well as the cookie tectonics activity. Once you're done with that, number 3 is a check. Number 4 is not useful, so I meant to delete it, but I forgot to, just because it's a confusing question that doesn't educate much, so we're going to skip it. Using the map of the Caribbean and what you just learned about plate boundaries, explain how the Lesser Antilles form. So focus on these features that you're learning about in here. If you're wondering where the Lesser Antilles are, they're in the Caribbean map. This right here is the Lesser Antilles. So it's this series of islands over here on the eastern edge of the Caribbean plate. A couple of thinking questions. Number 6 is exactly as what you think it is. And then number 8, and number 8 is a check. So 3 checks in this activity. One's pretty early on. You guys ready to go? Excellent. If you have questions, who can you always ask?
You.
Me. Thank you.
Did you guys? Oh, no, I'm fine.
Do you have a pencil?
No, I'm good.
No, I have one.